right? So for line A, right, we have C out arg C, right? So when we have our first arg, right, this is going to be the first argument over here. When we have command line arguments, the way that it works is that our first argument is going to be our positional argument, right? So that's literally saying based on the position that it's in. And then all of the other arguments are passed into this array over here. So it's as if you have your first argument here, and then all other arguments are inside of this array over here. So this means that we have 1, 2, 3, 9, which goes over here in our first one. And then the 9, 4, 5, 6, 9, and the 7, 9, 9, 8, 9, 9, 2 would go into the second one, right? And that would just be passed in as an array. So we'd have those two as in the array. So when we just say to C out arg C, right, we're going to just output that first one there. So this is just going to be the 1, 2, 3, 9, 1. Next, we have line B, right? And this is going to be for int I equals 1, I is less than or equal to 3, I plus plus, C out arg V, I, and then I. Okay? We C out and L, and so we're starting out at 1, right? So this is going to be within this array that I had mentioned before. And we know we have 2 arguments inside of that array, the 9, 4, 5, 6, 9, and the 7, 9, 9, 8, 9, 9, 2, 1. So if we're starting out at 1, right, we're going to say C out arg V at position 1, position 1. So I'm saying that I'm going to be going to the position 1, which will be the second argument, right? Because this is just an array. And we know that we're going to have position 1, and inside of that, position 1. So position 1 is going to give me 9, because 7 is the first argument, 7 is the first entry inside of this number, and 9 would be the second one, right? So with that being said, right, we would increment and actually, hey, Kevin, do you have the answer for this one by any chance? I just want to make sure that I'm doing this one correctly.
Yeah, 1 second.
Okay.
So the first, you're talking about C out as substring 1, 2 for the first part?
I'm talking about for part B, this one over here.
Oh, part B. 1 second, 1 second. Sorry, I just have to move. It's a little loud where I am. Okay. For part B, we have, let's see, int arg C, C out. Let's see, 4 int I. So we're looping here. So C out arg I. So, okay. So for the first, I can't really see very well here. Yeah. So we're starting from 1. So we're not going to be considering the ./a.out. We're only looking at 1, 2, 3, 9. And 1, 2, 3, 9, 9, 4, 5, 6, 9, and the other number, all those are strings. So another way to interpret a string is an array, where each index or each entry within the array is a character. Right. So we have a string of length 4 for the first entry, right? So when we're iterating I equals 1, that means we're looking at 1, 2, 3, 9. And then the second box that you have to the right of the first one, that's accessing the character. So you're looking at 1, 2, 3, 9, and it's the third character. Oh, sorry, the first, or so you have the 0th, and then you have the first. So it's the second character. In terms of enumeration, if it's an index, then you're looking at I equals 1, which is going to be position 2 in your string. So that's going to be 2. Yeah. And
Right.
so then when you iterate to the next one, then you'll have that argv of 2, which is that next value, is going to be the third character, so that's going to be 5. Yeah. Maybe it'll be easier to write out all of this like in a box, perhaps, just to see, yeah, like what I'm talking about. Yeah, like we can start with that one, and then you can break them up into 4 different cells, and then underneath each cell, just give them the index. That's 0, yeah, 1, 2, and 3, yeah. And then whenever we iterate, we start up from I equals 1. So we're not starting from 0, so we're starting from 1. And then we do this until it's less than or equal to 3. So that means we iterate from 1 to 3. Okay. So the last one, if you repeat this, that means your index is 3, right? So that's gonna be that last string. Because if you look at what's given, right, for the input, you have the ./a.out all the way until that last number with 7 digits. Yeah. So you have 4 strings there, right? So at I equals 3, that's going to be the 4th position within that string or that input, right? Because you can imagine that your input is itself like a set of strings, right? And those set of strings have a character at some position. So at arg3, we have that last number. And then at position 3 of that number, you're looking at 0, 1, 2, 3, so 8. I can't really see. Yeah, you got it. Okay.
Yeah. So that means we're going to output because each of these is separated by an endl.
Yeah.
2, 5, and then 8.
Yeah. So I guess when you approach these questions, look at the input itself as an array. It's an array of strings, right? So at each position of the array, so at each index, I have a string associated to it, right? So I have ./a.out all the way until 7998992, right? And this container is 2-dimensional. The first dimension being the strings, and the second dimension being the characters associated to that string. So that's why you have in this line for the for loop, you have C out argv 2 brackets, right? So I. So the first I is the first dimension, that's the string, and that second bracket that you see there, or the set of brackets, is going to be the character at that position.
Any questions on this one? Okay, so for the next part, right, we see that we have a string s that's set into argv position 1. So just as we said before, we know that this is going to be our first one, second, and third. So we know that 1, 2, 3, 9 is going to be set into string s, right? So we know that line C is going to say C out s dot substring 1, comma 2. So when we have the substring, right, the first parameter within this method is going to tell me my starting position, right? And the second parameter is going to tell me how far I'm going to look into the substring, right? So if we know that we have 1, 2, 3, 9, right? We know this is 0, 1, 2, 3 because each of these substrings is its own array. We're starting at position 1 over here. That's what our first parameter tells us. We're going a distance of 2. So we're going to take this and we're going to take this for a total of 2 pieces we're taking from that substring. So in total, we're going to have 2 3. Okay, that's going to be for line C. And now S is going to equal arg V at position 3. So that is this long string over here, right? So that's 7, 9, 9, 8, 9, 9, 2. And now in line D, it says cout S dot find 9, S dot R find 9, and then end out. So when we have find and R find, right? Find is going to give us the index of the first time it finds a 9. R find is going to output the index of the last time that we find a 9, right? You could think R from the right. So if we start from the left, right, the first time that we see a 9 is going to be over here, right? So it's index 0, 1. So the first thing it's going to output is a 1, right? That's going to be the s.find 9 because it was found, the first index that it found a 9 was in index 1. Next, our find is going to start from the right, and it's going to find what index is the last in time that we find a 9. Okay, so in this case, right, we're going to have it over here. This is the last 9 that we find, and this is going to be in index 5. So now we're going to output a 5. Now, if we notice, right, this is concatenated with this. The brackets over here tell us that we put the 1 and then the 5 right after. Then we go to the next line. So it's going to look as if we're outputting the number 15. But this is really saying output the 1 and then output the 5.
Just doing like one comment.
Mhm.
Notice how it says as find 9 and not the quotation marks or I guess the apostrophes for characters. I think that might be a mistake. I think that it shouldn't just be 9 as an integer. It should be a character because we're finding it within the string.
Right, that's a good point. So we know that these guys are going to be strings. So technically it wouldn't be the number 9, it would be the character 9. So that's, I mean, I'm assuming that it still meant that it was talking about the character, but just to kind of keep in mind, right? If you're trying to find something in a string, you want to find something in characters. You don't want to really use integers because you're not really using integers here. Okay, that is part D. Now we have S is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so we change what S is equal to. So now S is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So let's just put our little indexes here, right? So we know that we start out at 0, so it's going to be kind of looking like it's 1 off. Now we're going to insert 2, 3. So this method is telling us in index 2, insert a 3. Now, likewise before, this should probably be in quotes, the second parameter, what we're actually inserting. So just to keep that in mind, but I think honestly it's okay for this. But for this, right, we have insert at index 2, a 3. So index 2 already has a 3. So for that matter, right, it's not going to look like we change it to anything else. So this is just going to essentially look like it's the same, right? And this is kind of trying to trick you up, right? Because if you index this incorrectly, right, then you probably would have thought, okay, index 3 probably would have had, index 2 probably would have had a 2 in it, and then I would have changed that 2 to a 3. So this is just trying to like kind of test you, like make sure that you know your indexes, right? That's why it's good to kind of draw it out beforehand. Because again, we start out at 0, so everything's kind of 1 behind. So index 2 is actually going to have a 3 in it already. So now we're going to do s dot insert 1, 0, 1. So this actually was done correctly because it has the quotes around it, which is good. So insert in position 1, which is over here, right? It's going to be a 0, 1. So right over here, we're going to insert 0, 1. So instead of a 2 now, this is going to look like 1, 0, 1, 3, 4, 5, 6, 7, 8, 9. And that's exactly what we're going to output over here, right? So this is just telling us insert at this index, this string, well, the substring. So that would be 1, 0, 1, 3, 4, 5, 6, 7, 8, 9. So same thing, it's just we replace the 2 with 0, 1. Any questions about this question? Hey Kevin, quick question. For part A, is it referring to the argument count?
Yes.
Okay, so my answer was wrong. So yes, this would be the argument count, right? So all the other arguments would be in here. I'm sorry, I
Yeah.
think I was thinking of Python instead. I'm currently taking a Python class, so it's like I'm thinking of like positional versus
Yeah.
yeah. So this is
To
saying,
determine, yeah, sorry, go ahead.
yeah, arg count. So, right, how many arguments are there? Well, we have a dot out. We have 1, 2, 3, 9, 9, 4, 5, 6, 9, 7, 9, 9, 8, 9, 9, 2. There's 4 total.
Yeah. So to determine which is which, just look at int main. Do you mind just erasing the marks you made just around the function, the declaration for int main? To make things a little easier to see. Oh, okay, just move it. Yeah. Nice. Okay, 1 second. Okay. So it says int argc. So that just means argument count, but you can see that it's using the variable int, so it's an integer, so that's gonna be a count. And so char star argv, so that's just a character array, and the star is a pointer. So this just means that you have a array of characters, basically. Or rather, sorry, an array of strings. So each individual, everything that's separated is what gives you the string, but then you keep count of it with the argc counter. So you're not going to be writing anything explicitly for that. That's all handled by the compiler, but that's just for you to know which is which. So int argc is the counter for the number of strings that you have in your input, and then character star argv bracket bracket is just the container of the strings.
Any other
So
questions about this one?
yeah. Also another thing, can we go down to the inserts? Just make something
Yeah.
clear as well. Is that for inserts, we're gonna be basically just pushing everything to the side, right? We're not replacing. So for insert 2 at that position, but another thing is that 3 should not just be an integer again, that should be a string. So for insert, you're gonna be
Yeah.
using 2 arguments. In this case, you have the index that you're interested in to insert at, and then the second argument will be a string. So it won't be a character. And as I was saying before, when you're inserting a string into another string by using this function, you're going to be pushing everything else, or sort of, making space in between. So you're not going to be replacing. So for example, if I had the following, I'll write it in the chat, I guess. Or maybe not, because we're recording this. It's better that we actually write it.
Yeah, you want me to just
If
write
we
it
have,
down?
yeah. Yeah, so if we have like something like hello, right? So like we set a string equal to hello.
Yeah, so let's just say I have hello.
Yeah. And at the last index of hello, we'll do a 5. Right, so that's the last index is 5, yeah, because it's 0, 1, 2, 5,
So we
yeah.
could say s dot insert.
Or I'm
Right?
sorry, yeah, it's a 5-letter word, so it should be index 4. Yeah.
Okay.
Yeah.
So, oh,
And
sorry,
then
you're
yeah,
saying insert of 5 there.
yeah,
Yeah. So s dot insert, right? And we're entering it into position 4, right? So
yeah.
the
So just
first,
erase the 5.
yeah.
Yeah. And then you can just do a string, so you can just do a space and then world. That if you're to print that out, then you can get hello world.
Yeah. So let's just say I had the word world over here. Then this would be replacing over, well, wait, this would be replacing over here though, the O.
It's not replacing it, it's appending it at this point. So it's inserting, so it here, instead of like doing world over O, so actually let me see if I can't write. Yeah. But yeah, instead of replacing the O, instead what you're doing is you're just adding a character at that point. So like right after 4, you're gonna be doing a space and then world. So the space happens because you explicitly define it. So in the string that Lauren just wrote on the side, so for the argument, it's just quotes, and there's like a little staple on the bottom. Um,
I don't have enough room. Okay.
yeah, gotcha. Yeah. So you can just write it on the side just to
Yeah.
make it more clear, I guess, like right underneath. Yeah, just yeah. But instead of just it being world, it'll be a space like before W. So it'll be space and world. Otherwise, it'll just be hello world, but concatenated together. I think it would be better if I just demonstrate on VS Code.
Yeah. Do you want to share a screen? Go ahead.
Yeah. You can see that, right?
Yeah.
Yeah, so this is what I mean. So let's say we have a string s equals to world. Let's just see how these functions work, right? So that's it. Okay. So if I do s insert, right, position 4, or if I want to get the last value of the string, right? Because I can just try out different words, right? So I'm going to set n equal to s dot size -1. Right. So what this does is just gives me the last index of the string. Right. Because I take the size of the string and I subtract 1. Because yes, in the case of length, this is a sorry, not world, I meant hello. Yeah. So this is a 5-letter word, and I guess if you were to enumerate each letter, you get 1, 2, 3, 4, 5. But in this case, we're doing indexing from 0. So that last character would be position 4. So you can just say the size of the word -1 to get the last character or last position in a array. And remember, this is an array. Doesn't look like one, but it is. This is a string of characters, also an array of characters. But yeah, just a trick to keep in mind when you need to access the last element. Right, so at this position, let's just try doing world. Okay, and let's print it out. And so as you can see, it says hello worldo. So here I inserted world at that position O, right? So if we're looking at this, starting from hello, right? So this is position 4. So let me actually do this. Just do multi-line comment instead. Right. So this is position 4 right here. So at this position, I insert world like that, right? So I get hello world O or hell world O. All right. But if I do a space here, let's see what happens. Hello world O. Yeah. So we have to be careful where we insert. So if we do it at the end, as you can see, it actually inserted at this position for the space that I have here. All right, so that's a space character. Even though we have nothing there, this is still considered a character. It's just it's a like a blank character. So if we wanted to insert hello world, let me try something. Let me try this. Let's try doing +1 instead. Let's see if it actually does it at the end. Okay, great. So here you're basically inserting it at the end. So after the 4th position here, which is gonna be 5, right? So I just added 1. So basically I'd just be erasing this and just replacing that with this. Yeah. But hopefully I think now we all get the idea as to how the insert function works. Let's do another example. So let's do, instead of hello, we'll do 1, 2, 3. And let's say I want to insert, actually, let's do this. Let's do 4, and I want to insert 3, right? So let me get rid of this for now. And let me insert it at, let's see, this is position 0, 1. So let's try inserting at 1. And instead of world, we'll do the character 3, which we'll need to do a 3 here for the string. Okay. Yeah, there we go. Oh, sorry. Looks like I'll need to do the other way around then. I need to do 2 then. There we go. So yeah, okay, I see. So you have to insert it at the position that comes after. So this is 0, 1, and 2. To remind myself of the insert string method. Okay, so you have 0, and then we have a 2 here. This is position 1. So if I want to insert, and currently I have 4 at position 2. So if I want to shift 4 and then insert a 3 between, then I'll just do insert 2. So that's the position 2. So that's going to be at this position, right? I will basically replace this 4 with a 3, but the 4 gets shifted. And so I have a 3 now. I set position 3 now. So that's what I meant by when you insert strings, you're shifting everything else after that position. So I guess we can move on to the next set of questions. Anyone have any questions on this actually? All right. I guess we can move on to the next set of questions, I guess. Stop sharing this.
Are there any requests for questions to cover? Or topics we can go over? Whatever you guys feel like you want to kind of go
one.
over.
There's another one. Write a function that called rotate that takes a string of lowercase characters and changes every character with the next character in the alphabet. Character Z rotates back to A. Sample program uses this function follows. Okay, I see. I'll do this one. Yeah, of course. All right. Have this. On here. 1 second, sorry. So let me go back to the question again. Actually, hold on, you mind reading it? I saw it was like.
Yeah, I got you.
Oh, I
Right.
see. It returns a string. Yeah, go ahead. Sorry.
Yeah, the sample program for int main, you're gonna have string s is equal to quote ABC. Oh, you got it over there. Yeah. Okay, so we know we're taking in one parameter, right? So whenever you do like a function question like this, you always want to work on your title line first. So you probably have got like a lot of practice on those title line questions, and there's a reason for that because every function needs a title line. So I always like to break it down into a few different pieces, right? You have your return type, you have the function name, and then you have your parameters inside parentheses, right? So the name of this function is going to be called rotate, right? And we know we're going to be taking in a string of lowercase letters and changes every character with the next character in the alphabet. So we know our parameter is going to be a string that gets taken in, right? And we're going to essentially be, um, we don't need to necessarily return anything because we're going to be just changing it permanently, right? So anytime that you hear something that's going to be changed permanently, right, that's going to be a void function. And we know that because we know that it says just rotate s in the sample code, right? So it says rotate s. So something happens to the string s, and then we output it. So all we care about is that the result is saved somehow. So we're not going to be returning anything there. We just want to make sure that it actually gets saved permanently. So for this reason, right, we're going to do a void rotate, and then in parentheses, we're going to take in a string s. But again, we want to make sure that this gets saved permanently. So whenever we do that, we need to do what's called call by reference. We need to write the ampersand on it. And that's going to allow us to save our results outside of the scope of the function, meaning outside of when that function ends up returning, right? So it saves, like it's saving your progress essentially. Kevin, are you writing on the screen or no?
Yeah,
Oh,
I will
okay.
be. I was waiting for you to finish.
Gotcha. Yeah, go ahead. Go
Yeah.
ahead.
Yeah, so we're just rotating it as in just shifting it to the next one, right?
Yeah, so I was just kind of going over the title line first, right?
Gotcha. Yeah. All right.
Let me just want to write that in.
Yeah, so I was just waiting for you to finish. All right, so since we're not returning anything, it's gonna be void. And the name of the function is rotate, and we're taking a string. We'll call it s, I guess. Yeah. All right.
And then don't forget the
So
ampersand because we have to save it.
yeah.
Actually, well,
No,
wait,
I
strings
didn't
are an
put it because
array.
I was thinking because I was thinking maybe it's not, but we'll put it.
Yeah, so whenever you have
It's
an
good
array, right? We
practice.
know strings are an array just from the last question.
Yeah.
Arrays actually do save permanently. So
Gotcha.
because of that, we don't necessarily need the ampersand, but it's good to have it regardless.
Maybe we can just test it real quick. So let's test string h equals to u to rotate s. Obviously, this is not the function, but I just want to test if that's changed. So if this does work, it should replace it with hello, assuming it's not needed to put ampersand. Let's see. Okay, so you do need to put the ampersand, otherwise it's not going to call by reference. Yeah, so when you call by reference, you're just referring back to the variable you put here as your argument, in this case h. So then when you do this function here, it's going to reassign it to hello. And so the change is going to be propagated into the main function. Otherwise, the changes are local, meaning it'll only happen within the scope of the function rotate. So if I didn't put the ampersand, it would just be changing s to hello locally within that function, right? But if I put the ampersand, now it's a global change, right? Or at least from where I call it. So here, within the scope of main, h is going to change now because I've put the ampersand here, right? Because when I call rotate, the change will be made, and that change will propagate to main. Okay. So that's why the ampersand is important. Okay. So the function is doing some sort of shift, right? So we're going to be iterating across the string. So we're going to be doing a for loop beginning at 0, right? Indexing from 0 so that we can go through each element. And we're going to do this for the size -1. So we're going from the beginning to the end. Okay. So we're going through each character. So S of I, right? We're doing some sort of rotation. Right? So there's a couple things that you can do. So for one, the way characters work in C++ or in most programming languages is that you have ASCII, right? And what ASCII does is it assigns to each character some unique integer. And the characters we're working with here are alphanumeric, or in this case, I'm sorry, just we're looking at alphabet characters, so they're called alpha characters. So what we can do is apply a shift in the following way. So we can do S of I, right? We're going to be doing minus A, right? So what we're doing is we will be subtracting. So this is a weird operation at first glance. What we're doing is subtracting the positions. We're not actually subtracting the characters. So what the compiler is going to do is interpret this as numbers, right? Not as characters. So when you do this operation here, you're going to be shifting it, but we're going to have to offset it by 1. And then we're going to take the modulus of this 26 because we have 26 characters in the alphabet. And wait, question, Lauren, are all the characters lowercase?
Yes, they are. It's a string of lowercase letters.
Okay, gotcha.
And
So
it
then we
changes
can
every
work with
character with the
this.
next
Yeah,
character in the alphabet.
yeah. And then we're gonna reset it back to hey, so okay, so this is what's happening. All right, so we subtract the position. So A has its own ASCII character, or sorry, its ASCII value, some integer. We're subtracting positions, we're offsetting it by 1. We're taking a modulus 26. So this allows us to wrap around. So if we didn't add the 26 here, we wouldn't have some other character outside the scope of the alphabet. So it'll be some like bracket or some curly brace, or whatever index is associated to that character, right? And then we're adding the character A to keep it within the scope of our alphabet. Okay, so this is going to allow us to shift. Yeah, and this offset here is basically shifting it by 1 to the right. So we take
Wait,
the
question,
difference. Yeah,
Kevin. Um, wouldn't we also kind of be able to just like add that one to the character, like just kind of each time, and then like for the one case, because it's only doing it to the next character in the alphabet, and then like having maybe a condition just testing if it's at the end, if it's Z, then to just kind of loop it back to A. I'm thinking that might be kind of the easier way of doing it.
yeah. So let's write down what you said in code. So just wanna so you're suggesting that we add only 1 to it and then take the modulus of the 26 without using these characters here?
Well, since it's like based on characters, right? If you add one to it, doesn't it just
Yeah.
automatically change the ASCII value for that?
So you're suggesting just adding 1 to the character. That's it.
Yeah. Yeah, because we know it's lowercase characters, so it'll automatically add
Yeah.
to the ASCII. Like I don't think you need to include the A there.
So the problem with this, if we just include um like for example, this is a character, right? Because we're looking at the strings index, right? So S sub I. If we add 1 to this is going to give us, hold on, let's just test this actually. I'm curious. Need to, so I'm thinking this might be just an integer, but let's see. All right. See out of this. Let's keep ourselves. Oh, that was loud. Hello. Let's do this. One. Let's see what the output is here. That gives us a number, 73. So
Okay,
now
so
let's mod this by 26.
what if we just converted it to like a character,
This
like
is
you
not, yeah,
character
this is
wrapper?
not going to give us a character, by the way. This is just going to keep it within the range 0 to 25,
What if
which
we
is what we
just
want.
use it? What if we had it before, but we just use a character wrapper class?
No. Um, actually, yeah, actually we could do that. But
Yeah.
yeah. So if we do this,
So a wrapper class essentially allows you to convert
sorry,
a
I said no very quickly because you said class. This is a function. Just sorry, just a little fix. But yeah, but you're correct. This is we can also use this. But this is another approach. I want to explain this again because I didn't do it really well before. But
Okay,
this also works.
just do
Let's
the
test
wrapper
this.
one first, just to kind of make it a little simpler for the for everyone so they understand like what is going along and then go over the other way.
So notice that this gives us I, right? So that's seems very random, but what's happening is I'm first going to convert this to okay, so this is how it works in C++, right? So if you add a character to a number, what's going to happen is you're going to get an integer. Why does that happen? Because when C++ sees you adding a character with a number, it interprets this character as the ASCII value it's associated to. So in this case, it'll be some integer, right? So since we got 73 before, that means the ASCII value of H, capital H, is 72. So by adding one to it, we get 70. However, this character function that Lauren suggested is a wrapper function, right? That allows us to acquire the character um, associated to that value in the ASCII table, right? So it's a lookup table, right? Which character is associated to the number 73? In this case, it's the letter I, right? Which makes sense because it comes after H. All right. But the thing is, we're not actually getting a lowercase character, right? As a matter of fact, we're lucky we even got a character here. So to fix this, right, we first take the modulus 26, right? So we keep that number within a range of the alphabet, or the number of characters within the alphabet. We have 26 letters. So the mod operator, just to remind you, takes the remainder after you divide, right? So it gets the remainder after you divide. So in this case, you're dividing 73 by 26 and get a remainder, right? So you're going to get an integer output, right? And so you're going to keep this number, whatever you get within what I just highlighted, within a range of 0 to 25, right? Where 0 represents the number, represents the letter A, and 25 represents the letter Z, right? In this case, it's just the entirety of the alphabet represented within that range. Now, to get the lowercase letters, what we're going to do is we're going to add this to the character A. Okay. So now
Kevin, I
we
think the
should.
reason that it gave you a capital letter was because your string had a capital H in it. Because it's supposed to be assumed that it's all
Oh
lowercase.
yeah. That's just well, I'll be honest, the fact that we got the capital letter I is not really significant. I'm not really trying to fix this to keep this within the range of lowercase letters. I'm just explaining what um this line is doing here. That's all.
Yeah, go ahead. Go ahead. I just want to make sure
Yeah.
you're on that.
Yeah. I mean, I'm not. The objective here is obviously to get the lowercase letters, but yeah, this is just getting that first uppercase letter because H is capitalized. But yeah, but now if I add this, I should get let's say I get 118. Um, so I guess I gotta apply another character wrapper around this. This gets very complicated now. Let's see. Okay, we got a letter V now. Okay. So yeah, so we'll do something like this. Right. So let me, I guess we'll use the implementation we just had, right? So why am I adding by lowercase a? Well, because after we acquire something within the range of 0 to 25, by adding the lowercase a, we're going to get the character integer value associated to the lowercase a, right, within the ASCII table. And then we're going to be adding this offset here to be calculated, right? So if that's the case, then let me just erase all of this. Let me see if this also works here. I should also get this character. Sorry. Just get this. Should give us a character. So we give V again, right? So Don't worry about this output. I'm just testing if it actually gives us the lowercase letter. All right. So let's do simple implementation. So here I want to set this equal to, so we have s sub I, right? We add 1 to it. So this gives us an integer. So we get the next integer, right? Sorry, so we get the integer of this, and then we add 1 to it, so that, shifts it by 1. And we take the modulus 26, so it wraps it around, right, and gives a range 0 to 25. And then we add the letter lowercase a to it, right? Because you can imagine like this is a starting point, right? So it begins at lowercase a, and since lowercase a has itself an ASCII value, right? Lowercase a's ASCII value. Let me see if it actually shows up here. So here, yeah, here you go. So char 97, right? So I'm going to get 97 as the value associated to lowercase a. And this is going to give me an offset, right? Within the range of 0 to 25. So if I calculate this using a, like let's say we have s sub I as a, this is going to add 1 to a. So in this case, it's going to give me 98 because a's ASCII value is 97. So 97 plus 1 is 98. 98 mod 26, that should give me 1. And 1 plus lowercase a. So lowercase a's ASCII value is 78, right? So 78 plus 1 is 79, right? And then at the end, I'm going to take the wrapper function, char, and convert that ASCII value into a character, right? So 79 as an ASCII value is B, lowercase b, more specifically. So now we've successfully shifted each letter. So I think that should be it. It's only rotating it. So let's see what the outputs are. This. I don't know. Why does it keep doing this? Whatever. I'm just going to do this equals to that. Strange. I think I copied an illegal character after I ported it from the Zoom photo. All right. Let's do this. Okay, rotate S. All right, so let's actually write down the output before we even do anything. So it should be B, C, D, A. After Y is what's after Y? A, B, C, D, E, F, G, H, I, J, K, L, M, N, P, Q, R, S, T, U, V, W, X, Y, and Z. Sorry, Z. And then X after X is Y. Sorry. Yeah. All right. Okay. Now if we run this, let's see. Sorry. Let's do. Oh yeah, I gotta print it out to see what it is. So let's print out S. A UVWTSX. That doesn't seem right at all. 1 second. Maybe I did something wrong here. So I plus 26 plus A. Let me try something else. Let me try doing this and plus A. Strange. Same thing. Yeah. Let's see if I add 1 to this, I offset it plus A. Why does it give me UV? And it should give me 79. Offset that, 78. Actually, let me print out what these are before I even do anything. So let's see how I'll fix this. I'm curious what this is. So maybe that'll give me an idea as to what's going on. So if I mod this by 26, actually, sorry, let me just do this. So 99, 98, 100, 123, 122. Oh, I see. 90. Okay, so that's 97. This is 98, right? So if I take this and wrap it around with the character, I should be getting see BC. Okay, so yeah, I got these letters. So notice here I have this curly brace left facing. So it's a left facing curly brace because it's not wrapping around properly because here it's doing Z, right? So this is basically 1 plus Z. So we get this curly brace. So the ASCII value for this is let's see. Well, it doesn't really matter. It's 1 after like whatever the range is for the alphabet in the ASCII table. So if I wrap this around with 26, then I should be getting, sorry, not in there, in here. I should be doing it in here. Okay, 26. Okay. Interesting. So I guess that doesn't work if I do mod 26 for some reason. It prints out blanks, which is really weird. I do no blanks. Sorry, let me actually see what this is. What is this printing out? Let's see what this is. This is 20, 21, 22, 19, 18. Okay. Right. And so if I do that, 20, if I do the character of 20, what should I get? I guess it's undefined. Let's see. Okay, so I get blanks. So I guess it's not defined. All right. That's okay. I see. So if I'm doing this mod 26, and then if I add a, let's see, character SI plus 1. Okay. I want to keep this. So if I do 20, let's see. Do 20. 20. Character. If someone do this, let's do this. SI plus 1. Mod 26. Yeah. And then I want to do this plus A. Just wrap these around here. Let's see. I get 117, 118, 119, 116, 115. Okay. So the position of A is 98. Okay, I see what the issue is now, I think. So I want to, so if A begins at see, A begins at 78, right? So we said, I'm sorry, 97. Oh, I said that. All right, 97. So here I calculate this. This is going to be an integer. So I would like this to be, let's see. I'm wondering why is this so large? Let's do, yeah, because it was very large before. Why was it? I think it's 20, 21, 22, 19, 18. Yeah, these are very large. It should not be, um, oh, I think, let's see. I guess it's not calculating the modulus correctly. So I'm noticing that this is 20, 21, 22. So that means there should be 0, 1, 2. Because there should be 0, 1, 2. So I want to reduce this somehow.
Kevin, I think it might be best to maybe just work on another question for the time being. Like, we don't want to spend all the time working on this one.
I'm sorry. It's just that I thought that you can, because I know what the issue is now. It's just that you need to, instead of adding like these large numbers, so I guess this here, right, is calculating the position one to the right of, oh, let's not do that. Let's not do one plus that. Let's do this, right? Let's mod this first and then add one. Let's see what this is. So it's doing the offset before modulating it, or taking modulus. Like it's been the same thing. Yeah, it's the same values. Interesting. Yeah, I guess that made sense if I were to do that. Take the offset and then modulate it. Am I flaking out on this one? Let's see. SI mod 26. Okay, let me try this. Let me try doing minus this. I'm sorry. I just want to do one more attempt. 78, 80, 81.
So I checked it.
Okay, yeah. I think, yeah, this looks correct now. So now if we take the character of this, OPQHG, no, that's not right. Why is it doing that now? Doesn't make sense. Oh, wait, I think because oh man, sorry, it wasn't 78. So it should be 97, so it should be 98. And then yeah, I'm sorry, what'd you say, Lauren?
So I just checked it on my own, and
Yeah.
so I think that you can kind of just do it like with doing like the way that we kind of had it before. Um Actually, you know what, just it's okay. Just leave it like this. This is all right.
Oh, you mean oh, right. You mean this form, the one I did before, which
No.
was
Just it's okay. Just continue with that. It works now, so. There was
it doesn't
another.
work.
Oh,
It's not giving us the right characters because these ASCII values don't match. I
okay,
think you're
because the way
referring
that
to
I was
this.
looking at was saying the code says if C is okay, so you know what I was saying, like having like a case for
This.
yes, you could say like the like
Yeah.
having a case like if
Yeah,
it's
it
C,
works
you know,
now.
if C is equal to character Z, then C is equal to character A now. Else you take your character and add one to it. That's what I seem to be getting after I looked it up. I think if anything, maybe doing that with the character wrapper around it. Right, I'll send it to you in the chat.
Well, the one I just wrote using this instead of using the character wrapper, this gives us BCDAZX.
Yeah, honestly, I think it might be the
Yeah,
modulus by 26 that's giving it some issues.
I don't think that's the case. But yeah, let's just move on to another question then.
Yeah, there was another one that was posted in the chat.
Yeah.
I'll send it again. Write a program that asks the user to enter three positive numbers. It then writes each entered number to a file called number.txt, one number per line. The program validates each input and ignores those less than or equal to 0. At last, it prints out the sum and average of three positive numbers.
We return the number.
We want to write it to a file called number.txt. So basically, if you have if it asks the user to enter three positive numbers, and then each of those numbers, if it is positive, gets written to the file, otherwise it gets ignored. And then it prints the sum and average.
Does it print that average also to the file?
It just says it prints it. It doesn't write it to the file, so I think that would be just to the output console.
Okay, what's the name of the function?
It's a write a program, so it's a whole program.
This program?
No, like it's like literally would be in the main function, but okay, you could write a function too.
I'll just call it program. I don't really care.
Yeah,
Right.
okay, you could just put it into a function, that's fine.
Enter some input. Now we do the get line function. So this one, there's not really any intuition that comes to it. We just need to know it. It's kind of a boring question. So just do cn, and then you'll take an input as a string. So string user input. Okay, user input. Right. Okay, and then we have to write it to a file. We're not gonna do anything fancy where we write it to a directory. I'm just gonna write it to whatever directory I'm working in right now. So offstream, out file. Like this, you just need to know, unfortunately. Output txt, I guess. What's going on now? Incomplete offstream is not allowed. Is it because I didn't write the fstream thing? Let's see. Stream. Okay, yeah, that's why. Yeah, so you also have to make sure that you have the correct directories, or sorry, not dependencies included. Okay. So we also have to check if the file is open successfully. So I'm just writing I guess like the boilerplate for this, and then we'll actually write in the logic that we need. So sir, so this is a C out error, but it's just concatenated as a C error. So it's like, we'll say it's an error. Opening the file. Oh no. Right. Then we return 1. So when we return 1, we can't do that actually. Let's just do this now. Now we're good. Now we're in business. So return 1 just means there's just been an error, not returned successfully. Otherwise, we return 0, which means good in shape. Okay. All right. So now I'll put the user input. We close the file afterwards. Okay. And we can also include a message at the end. So we can say your file or input was successful. All right, so let's just test this before all goes wrong. So yeah, I guess I'll have to do this. C out. I have to do C out because I can't just actually let's just do this. Let's just do program. I think there should be fine if I just write like this. This is a return value. Typically, I don't like writing functions like this unless they're voids. But in this case, I'll make an exception because we're just only looking for user input. So this is obviously not the final answer. This is just to show how to set up your user input. So we get our input and then we save that to the file. So we're asking the user to, I think the question was to ask for 3 positive numbers, right? And then take the average of that. We'll do that after. But I just want to see if this program actually runs. All right, so I'll just do hello world. I don't think I need to put quotations. I could just write hello world. Right, yeah, great. So my output should be here. Yeah, beautiful. That's my output. Okay, so since we're able to save output successfully, Lauren, just to confirm again, just 3 positive integers and take their average, right?
Yeah.
Okay, great. So we're not really changing much. We're just asking for 3 positive integers. Is there any exceptions, any like issues if I don't put any integers in?
If the integers are less than or equal to 0, it ignores them and just doesn't write them to the file.
Okay,
So you're
sure.
probably gonna have like an if statement like, hey, if this is positive, then write it. Otherwise, do nothing. Go to the next one.
Got you. Or I can just, before I even write anything, I can just check. All right.
Yeah.
Um, okay. Well, now I'm thinking about just using this then. So int arg, wait 1 second. You have another idea, because if we're doing that, it might be easier just to introduce this then. So int arg, no, sorry, car. I don't have to get this exactly right, but I'll just write it like this. So starting here. Okay, so I have to check if they're integers. 1 second. So let me think. I have to convert the string to an integer. Okay, so convert the string to an integer. So I'm given just the number 1. Could I just use the int? No, that won't work. Convert them to integers. What's the conversion function again from a string to integer? Lauren?
Um, couldn't choose like the int for the
No, if I use the int wrapper, it'll just give me the ASCII equivalent, and that's not going to work.
I'm sorry.
Otherwise, I'm going to have to offset it. If I use the integer wrapper, it'll give me the ASCII equivalent.
Yeah. I'm sorry, just one more time. What do you want to do exactly?
I just want to convert a string to an integer. Oh, I think I remember now. I think it's like stow a, yeah, it's like this. It's like store integer, I think. I'm sorry, yeah.
Yeah, it's S2I, so it looks like stoy.
Yeah. Okay. The other issue is just parsing through it. So C out, enter some integer, some input. See, sorry, it's just the issue is I have to also separate it. So you're given the input is a string of, I guess you're gonna be separating it with spaces. But I think if I just do a for loop. Let's see.
Well, you're getting each line based on the input, right? So
No, yeah, I'm just saying because you have to separate it with some separator, right? So in this case, with a space, right? But the input itself is a one-dimensional thing. It's a sentence basically.
wouldn't
So
it be easier to just process it each on its own? Like print, I mean, like process each like integer on its own, essentially.
but integer could be like 50 or 542. Like how would you determine like, if you're separating it or not?
No, like take in each of them at like one point, like see in, check if it's good or not, and then write it to the
Oh, okay, gotcha. So we're not parsing, we're literally
yeah, no, no,
just
no, no, no. Don't parse it. I think that you're making it more work for yourself. Just take in
oh, okay.
each integer and then test
I
if
got
it's
you. Yeah, yeah,
positive, and then
gotcha.
if it is right, it otherwise just go to the next one.
Yeah, okay, gotcha. All right, so I'll call it temp input. We'll call this user input. Yeah, sorry about making it overcomplicated. I was just thinking about parsing it. All right, string. All right, so C out, enter your first in. Oh, sorry. Someone's trying to get in. All right.
I got it, don't worry.
Enter. I got it. Enter your first integer. Input one. I guess yeah, we'll just call it input one. Just assigning it 0 so that it doesn't assign it garbage. Otherwise, if you don't assign anything to it, it'll just grab whatever in memory. And I don't like doing that. Just give it some temporary value. 0 doesn't hurt. Right. C out, enter your first integer. So C in input one. Right. And as you suggested, we would check. So if so I believe it's this, right? Input is greater than or greater than 0, right?
Yeah, because it has to be greater than 0.
Second, yeah.
It'll ignore anything less than or equal to 0.
Yeah. Am I doing this incorrectly? What's going on here? Oh, I see what's going on. It should not be taking that in. Yeah, I should be taking the temp input in. Okay. Temp input. I gotcha. All right. So this converts it to an integer and it's greater than 0. If that's the case, then what do? We just save it. We'll just do
We
that
write
again.
it to the file, yeah.
So yes, all right. So I'll just I guess we'll just user input. I'll do this. I'll do temp input. So an end line. Okay. So it just writes it to the file, and this is just skipping a line, basically. All right. Okay, and we just repeat this, I guess, for 3 more values, or 2 more.
Yep, total 3.
So not your first, it should be your first. All right. Second, and then your third. Otherwise, if it's not, then what do? We just keep on asking the user to
Yeah, we
input it.
just it then okay, write a program that asks the user to enter 3 positive integers. It then writes each entered number into a file, one number.
No. I meant like the else condition. Like if it's what if it's less than or equal to 0?
Ignores those, and it prints out the average of 3 positive numbers. So it doesn't tell you really like I mean, I guess because at the end you have to find the average of the 3 positive numbers, you have to keep going until you have 3.
The question. So do you take the average of those numbers that are not 0?
No, it has to be only those that are like
Yeah, that's what I'm asking. So,
yeah.
for example, I only input one number, it just takes the average of that one number. So it's just it prints itself. This is a funny question. Okay, we'll run with it. So, all right. Let's see. Wait, why did I write this again? Oh yeah, that's right. Right, right, right. So then I want to store this input 1 equals to this temp input. Just repeat this again. Yeah, and so I could just keep repeating this because then here this is not going to um, like I'm just gonna keep on replacing temp input anyway. All right. All right. Oh yeah, and I have string user input because I wanted to include this onto the which I did here. So at the last one, I don't need to include this end line. I could just do this instead because it's going to be the last one anyway. Okay. So get line. So I don't want this anymore then. I just want, I don't have to do this anymore. Yeah. Because I'm not taking input again that way. I'm just only taking input this way. So I'm doing a CN in 3 different lines. And at the very end, I check CL file. File. No. Yeah. Okay, that's good. And then output user input. Sorry, I'll file to user input. So I save that user input to the I'll file. And then if it closes successfully, prints out that message. Okay. All right. And then we wanted to print out the average of the numbers, but I'm just confused because I guess I'm just taking the average of only those numbers that are positive. So that's the case then. Um I'll do a running average sense of average. Okay. So if we're gonna be doing this, I guess we can just do this average plus or equals to the input. Okay. And then if we get to this value here, I guess we'll also do this here. So average plus or equals to input 2. Well, we'll make it as simple as possible. Like even if let's say you input 1 0, it'll still take the average of all 3 numbers, right? We'll just do it like that because it'll just make it more complicated if we just only take the average of those numbers that are positive because then you have to keep track of those conditions, right? So then we'll just do average again plus or equals to temp input, and then we will print out the average here. So the average is as follows. It's the average of 3 numbers, right? Okay. And just to make sure that this is a double, we'll divide by 3.0. What's going on here now? Oh, sorry, this should not be temp input. It should be input 3. Okay, so input 1, input 2, input 3. All right, so let's see what happens now. So let me just erase this. And let me do the program now. All right, so let me compute the average of 3 numbers. What's going on? First integer, let's do 5. Second integer, 5. Third integer, 5. The average is 5. All right, so let's see what the output is. The output's 555. Great. So yeah, we complete the program under the conditions given. So let's do it again. Let's do another example. So let me do 2, 3, and 4. Average is 3. Right. This is 9. Divide 3, get 3. Yeah, let's do it one more time. Let's do 1, 2, and 3. I'm sorry. 1, 2, and 3. Yep, average is 2. Great. And as you can see, it saves it here. It does it by each line. So if I didn't actually do this over here, so if I didn't have this end line thing, then it'll be something like this. It'll print everything all on the same line. So you can see 1, 2, 3. So if you want to separate it on each line, then you need to include that end line character like this. Okay. All right, I guess we can move on to the next question. Unless anyone else has more questions on this for chat. Happy to answer that.
If anyone has any questions or other questions that you want to go over, just send them in the chat. Are there any other topics that you guys want to go over or anything for the exam? I mean, otherwise, I would say like kind of the best thing to do, just kind of keep practicing like a variety of the questions that your professor
Yeah.
posts.
Just before we go, I do want to fix up one thing. I just want to apologize. Sorry for taking too long on this question. We got mixed up in the beginning, just trying to shift this. I do want to find a fix for this so that you guys don't go out of this review session without knowing what the answer to this is. So, um,
In the
just give me one
meantime, if you guys
second.
want to also fill out the feedback form as well, which I just posted in the chat.
Oh, I see what happened. I shouldn't be subtracting by 1 here. Sorry, this should not be. I just realized that. Um, because before, yeah, because this is the approach that we took before, and it actually shifted everything but the last letter. So I was confused, but then I realized it was because I iterated just to short. It should have been the entirety of the string, not just 1 minus. Okay, so if I were to actually run this now, so let's do this. Rotate A, B, C. Something very simple, short. What's going on? Why aren't you cooperating? What's going on now? Rotate. Did I misspell it or what's the issue here? No instance of overloaded function rotate matches the argument list. Okay, let's just declare a string directly. So oh, I think I know what happened. Yeah, because the reason it was an error is because this is passed by reference. So I guess you can't just provide that value directly. So you need to provide the actual variable s. Because since it's passed by reference, it needs to have a reference. right? So S is the reference here. So it'll refer back to this within the scope of the program. All right. So if that's the case, then if I run this, I have to print that's before. Yeah. Yeah, there we go. BCD. That makes sense. All right, so that fixes it. So BCD. Because it just moves it up once. And if I make this in what's the last letter? Z, right? Yeah. So to make this a Z, then yeah, it should be BCDA, which makes sense because you just wrap Z around to A. So just to explain this one more time. So this is our letter, right? Some lowercase letter, and we're subtracting it. So this is a more complicated approach, but it's ultimately correct as we see here. So we're subtracting it by the ASCII value of A. So we're basically bringing it down between a range of, if we were to look at this, this becomes, let me just show you. This is, this will bring it within the range that we need it to be. Yeah, so as you can see, it's 0, 1, 2, and 25, right? So it takes the difference between the ASCII values, but when it's computing this, it's taking basically a distance. So the ASCII values, as I mentioned before, for each character has an associated integer. So this integer, this value has an integer associated to it. So when we subtract those integers together, we're going to get something basically represents the range. So A has character, the character A has ASCII value 97, right? And then we do this all the way until Z, which is 113, right? Because that's 26. So we do 6, 13. Yeah. Okay, we're good. Actually, no, sorry, it should be 100 and let's see. So, what is the ASCII value? C, just to remind myself. C is 122. Okay. Yeah. Yeah. Oh, yeah, it's plus 25. Yeah. Yeah. 25 plus that is 122. Yeah. Okay, so from A to Z, so you're basically reducing it to a range that allows you to determine what that letter is. Like if you were to do it from, let's say, 0 to 25, right? So when you take the differences between those letters, for example, if I had the letter A, so B minus A, right? This would be the same thing as saying in ASCII terms, since A is 97, this would be 98 minus 97, which is equal to 1, right? So we're not going to get, so if we do the character wrap around this, we're not going to get the actual character just yet. We're just going to get some, or at least we're not going to get the lowercase letter that we want. We're just going to get some character within the lookup table that's associated to 1. But we don't want that, right? So instead, what we should do is we take that number we got, so 1, and then we add it to the lowercase a to offset it back to its original place. So here we're actually setting this equal to this character here. So this is confusing because this is going to be returning an integer, but I think if I were to print this, this should also give me a number. Let's see. Yeah, it gives me a number here. This looks like a long number. That's only because I'm not actually separating it by line. And let me not put, yeah, I think that's good. There we go. So 98, 99, 197. Yeah. So these are the associated ASCII values, right? After we do this computation here. right? But then we're setting this number equal to this position, right? So that's confusing. But what's actually happening here is C++ is interpreting that this integer you're given, right, will be converted back to its ASCII value, which will be, in this case, B and then C, because this is a character, right? So when you assign a character to an integer, C++ is just going to assume, hey, you're asking for the ASCII value associated to that number, right? Which is the same thing that happens when you're adding an ASCII value, or sorry, when you're adding a character with the number, right? So you'll learn this in 316. It uh, actually is a concept called type conversion, and it allows for robust code because otherwise you'd just be running into errors all the time, right? So these conversions happen um, implicitly, because here I'm not actually writing anything down to explicitly say, oh, convert that to an integer before you add it. So yeah, sorry for not explaining that before, but yeah, I realize that it could be confusing. But ultimately, you're just taking it to the range of the ASCII value, um, and then you're converting it back to a character. Yeah. Stop sharing. All right. If there are no questions, we will end the session early. Any last minute questions? I'm gonna stop the recording then.